In this example, we're going to be looking at a different relationship between the concentration of hydrogen ions and the pH. So in this example, we'll be looking at when given the pH value, how do you work backwards and determine the concentration of hydrogen ions? So this question says, calculate the concentration of hydrogen ions in a solution that has a pH of 10.8. So we know that we have a pH equal to 10.8, and our unknown is going to be the concentration of hydrogen ions. So in this case, instead of using pH equals negative log of the concentration of H+, we will instead use the concentration of H+ equals 10 to the power of negative pH. And then we will just sub in our pH value. So this is the same as 10 to the power of negative 10.8. And then you type that into your calculator, and I'm just gonna go ahead and round it off to 2 decimal places right now for the sake of time. You should get something close to 1.59 times 10 to the power of negative 11 molar. So the reason why we have that m there in that molar is because we're calculating a concentration of hydrogen ions. So the unit needs to be molar, so m, or it would also be correct to say 1.59 times 10 to the negative 11 moles per liter. So that is the concentration of hydrogen ions in a solution that has a pH of 10.8. Another way that you can check to make sure that makes sense is that 10.8, you're seeing up there, that's a basic pH. It's a fairly basic solution. And since pH means the power of hydrogen, and more protons will make things more acidic, it would make sense for a basic solution to have an extremely small concentration of hydrogen ions, which it does. So it makes sense conceptually for it to be basic as well.